Hello, we're from Group 6
from COE 119 Laboratory.
Section E01.
and my name is Jana Raydon.
My name is Jonathan Bagisi.
My name is Elmerson Joshua Rael.
Good day guys, I'm here to tell you about our project applying interrupt 16H and interrupt 10H to reading file operation. The objectives to learn keyboard and video operation using interrupt 10H, 16H, and 21H. Implement the three inputs with different modes in assembly language programming. Discussion. Interrupt 16H or capitalized interrupt 16H or interrupt 22 is shorthand for BIOS interrupt call 16 hexadecimal. The 22nd interrupt vector in an 86-base computer system. The BIOS typically sets up a real mode interrupt handler, at least vector that provides keyboard services. This interruption is responsible for control for the PC keyboard. This interruption is responsible for obtaining basic keyboard functionality. It is also responsible for collecting the keystrokes, obtain the status of the buffer of the keyboard. Also, the standard encoding of the keyboard that offers the interrupt 16H is a US keyboard. To adapt the coding of the interrupt 16H to another type of keyboard. Here is the list of services of the interrupt 16H, given the function code, and the device that is applicable for it. Read key press. The function code is 00H, only the device is keyboard. Get the state of the keyboard buffer, 01H, keyboard also. Get the state of the keyboard, 02H, keyboard again. Establish repetition factor, 03H, again keyboard. Simulate a keystroke, 05H, keyboard. Get the ID of the keyboard, 0AH, keyboard again. Read expanded keyboard character, 10H or expanded, it is for expanded keyboard. Obtain status of the expanded keyboard buffer, 11H, expanded keyboard. Get expanded keyboard status is the 12H, also expanded keyboard. Using interrupt H00H, it checks to see if a character is available in the buffer. So here we are using function AH equals to 01H. If it's 0, it returns the character if it is available, and 1 if the character is not available. And using the function AL, it returns the value of the ASCII character code, and the function AH returns the value of the scan code. Interrupt 16H, 11H checks to see if a character is available in the buffer. This service is provided to support the extended keyboard 101 or 102 key keyboard. Using the function AH, 11H also returns the value of the character is available if the value is 0, and 1 if the character is not available. Using the function AX, it returns the value if the character is available, then set to character as in service 10H. Interrupt 10H is fairly slow, so many programs bypass this BIOS routine and access the display hardware directly. Setting the video mode, which is done infrequently, can be accomplished by using the BIOS. While drawing graphics on the screen in a game needs to be done quickly, so direct access to video RAM is more appropriate than making a BIOS call for every pixel. Here is the list of the supported function and the function code. Set video mode, AH is value 00H. Set text mode cursor shape is AH is equal to 01H. Set the cursor position, and AH is equal to 02H. Get cursor position and shape, AH is equal to 03H. And lastly, read character and attribute at cursor position, AH is equal to 0HS. So that's all.
So for our simulation, we need first to open our DOSBox software. So this is our DOSBox software, and what we need to do is to mount our C drive. So let's mount our C drive. Oh, sorry about that. So now that we have mounted our C drive, we can we can go to our C drive. So within our C drive contains the folder of our 8086. As you can see, it has its basic contents, except for this one. This is our project01.asm. So in order for it to run on DOSBox, we have to input its tasm. So let's do that. Tasm proj01.asm. And as you can see, it created a 3D object file, proj01. So now we need to link it. So link proj01. And as we link it created an application file called proj01. So in order for it to run, we just need to type in its file name, proj01. So this is the UI of our project. As you can see, the interrupt 10H or the video processing has been implemented already because it created a color blue background, as well as the color of our text into color yellow. So the operation of our program is to input a name, in which if we input the name, it will output the name at the middle of the screen, as well as creating a text file called data, in which it will contain the inputted name within the program, in the program. So to demonstrate or to simulate, first we need to input a name. So let's enter our name. So as you can see, it outputted my name on the middle of the screen, as well as it created a data file for it. So we can check it now. So before that, let's use the escape button to terminate the program. By pressing escape, it will exit the UI. So let's see the text file. So you can see it inputted our name, which does indicates that we successfully implemented the reading file operations for our project. So yes, basically that's the simulation of our project. Thank you.
Hello, welcome. We're here to break down the code for the project for Koi 119L EO1 laboratory. And here we can see that we're inputting a name. For example, we input my name. And the function and the line of code that makes that happen is, where is it? In this part. We use the move AH0AH of the interrupt 21H to make use of the input string and save it at par list. And then after that, we call the create a new file. And then it calls a create file here. Then after that, we write a file, and in that write file we open the file that we just created. Use the file handle that's here. We move the AX on the file handle. Then we input what we just wrote into the file, and we define how long the length of the string is into the file. and we exit the file using the OVH40 of the interrupt 21H. And after that, it brings back the values of the DX and AX because it was pushed earlier. Then we return here, and we do it all again up until if the inputted key is escape, which is shown here. 1BH in ASCII code, this one is the escape button. So if it's equal to that key, then it jumps to exit 1. So it exits the program after that. And that closes the program. Thank you.